Okay, so before going to coding of this AI/ML, so I will talk about this feature selection and some basic terms like overfitting, underfitting, this type of words. Okay, so just I will show you today about that. Okay, so today I will discuss about overfitting and underfitting. So what is overfitting and underfitting? Okay, so you are learning this ML models. Okay, so for that models, all the models you require some feature, okay, to make the model, to make the model. Okay, so what might happen? So let's say, so you want to make a model. Okay, say you want to make a model. So I'll make a ML model to identify whether a given object is an ball or not. Okay, so what is overfitting? Okay, so if I tell you that if a I will give you only one feature, okay, that is you can say as a shape. So if you train the model such that, let's say I will tell you, if you consider shape as a sphere, okay, if you see a object that it is sphere in shape, okay, then you will consider that is a ball. Okay, if you see the shape of the object is sphere, then you will directly tell that is a ball. It will be like that and it will be ball. Okay, so basically we are considering only one feature. Okay, so now I will give you a, let's say, Moshambi, or this you can say this is orange. Okay, if I tell you that I will give you orange, so you are trained that if you see that the shape of the object is sphere, then you will directly say it is a ball. So, but whether is it a ball? Is it a ball? Is it a ball? No, it's not a ball. It's a, you can say, Moshambi or orange. Okay, so basically what it is doing, so your ML model, so basically considering just one feature and giving out the value, but it is fitting all the sphere size object as a ball. It is telling that if you find any kind of sphere kind of object, then it will tell that, oh, it's a ball. But is it a ball? No, it's not a ball. So basically that is, that phenomena is called as overfitting. Okay, so so you have to take some feature so such that it will, we can call that as a ball. Okay, so let's say we are taking one picture, but we have to take many more picture. Okay, so let's say sphere. I mean this shape of the size is sphere, and whether we can play or not play. So it or not. So if it is satisfy all the this feature, let's say it is a sphere and we can play with it and we cannot eat this. So then it is called as a ball. So we are considering here three feature. Okay. Then it will be called base fit. Okay. There will be two terms are there, basically overfitting and underfitting. And in between these two, there is a call base fit we will use. So this is a base fit. Okay. So if we take one or more feature, let's say sphere, sphere, play, eat, and let's consider the radius of the ball is 5 centimeter. Ball is 5 centimeter. Let's we take a big ball. Okay, let's let's we consider a big ball with a diameter of 10 centimeter. But according to these features, so we are finding out that this is not a ball. Why? Because radius of the ball is greater than 5 centimeters. So this phenomena is called underfitting. Okay, underfitting. So in between these two, we will select the useful feature. Okay, useful feature. So that is called how to select this feature. So how to select this feature? So there are some feature selection techniques. So I will go through in details, but I will first tell you feature selection technique. So before going into this, so does anyone have any question regarding overfitting and underfitting? Any question? Okay. So if you want a graph, let's say the what will be the graph of overfitting and underfitting? Overfitting means like graph will be like this, okay, and the point will all fall in the line because it will try to cover all the points, okay. So that is called overfitting. And in this case, in underfitting, not one point will coincide into the one more, all the point will be outside of the line, okay. This is a figure of overfitting and this is a figure of underfitting. So in this case, all sphere, all the balls we will consider as a, if it is sphere, then we will consider this as a ball. But in case of this, okay, this four feature, we will not find many ball. Okay, only one or two may be satisfy these three conditions or four conditions. But in this case, many of the objects will satisfy. Okay, in here we are considering only one feature. Here we are considering four feature, but we have to take the best of these two. So how to select this? Okay, so feature selection technique. So basically there are three methods. So first one is filter. So filter method. Inside filter method, there are three another method IZ, not Instagram. So it is known as information gain. Okay, in here say score test. Then one is called correlation coefficient. Okay, then the second method is known as wrapper method. Wrapper method. There are two methods inside recursive feature elimination. So there are another called embedded method. In here, one of the method is decision tree. Okay, so I'll explain you. I'll also show you the first method. So filter method. So what it actually do? Okay, let us consider some A, B, D. Okay, so basically these are some feature. Okay, 1, 2, 3, 4, 5. 5 features are there, and this is the target value. Okay, this is the target. Okay, so what these filter methods, all the methods will do. So it will see where which feature is the actually this target is dependent upon which feature. So let's say if we these values, let's consider a value of 1, 2, 3, 4. Okay, Okay, sorry, my bad. So basically, I should have told earlier. So up to which point you have we are listening
So we haven't heard anything.
from here, from which point? From feature selection technique,
From that table, sir.
from this table, no? Okay, I'll explain it. So, so what is this feature selection technique? So this will be filter method will be there, wrapper method will be there, and this is embedded method will be there. So inside this, these are some methods we use. So this is IG, information gain, then C-square test, correlation coefficient, then wrapper method, and this is embedded method. Okay, so in here, so what we will do, so these are the some feature A, B, C, D, E. Okay, so A, B, C, D are, E are some feature. So okay, I'll have to remove this. So if we consider this 2, 4, 6, 8, 10. Okay, 1, 2, 3, 4, 5, 6. So this is the target feature. This is the target. Okay, and this is the A we are selecting a one feature. Okay, so this feature is heavily is depend on this. Actually, if we increase the value of this A, then the target value will also increase. Okay, one, then two. Then you are saying that it will also increase. So basically, A is T is dependent upon A. So these are called as a relevant attributes. This dependent. If we consider, let's say one another attribute 1, 2, 3, 4. So this is the roll number of a classroom. Okay, roll number of a classroom. So in here, this is pass fail, pass fail, fail. Okay, so in here, these are your classroom roll numbers 1, 2, 3, 4, 5, 6, and this is 1 is passed, 2 is fail. Okay, so your pass fail will not depend upon your roll number. If your roll number is increasing, then the percentage of failing is increasing that we cannot establish. Okay, so basically your roll number is not dependent upon your pass fail. Okay, so that's why it is a kind of a irrelevant feature attributes. So in this filter method, we will remove this irrelevant attributes. Okay, so this is the use of this filter method. Okay, in case of wrapper method, so there will be, let's say, 5 attributes are there, and P is the target. Okay, so we will just combine A, B, then A, C. So we can get many like rep. Okay, so this is one kind of rep, this is one kind of rep, this is kind of rep, and you will get many combinations. Okay, so this is called rep method. Okay, so this will give some like model type of thing, and we have to consider all the models. Okay, so what is the difficulty of using this wrapper method? So this is a small data set. Okay, only 5 feature point we are considering, but in case of a large data set, let's say many features are there, so in that what we have to do for feature elimination, or in here we are doing the feature filter method, that can be done, but we cannot use the wrapper method. Why? Because it will increase the time complexity, it will take more time. Okay, so basically This is the disadvantage of this method. Okay, so it is also will give us some problem, that is overfitting also. Okay, so this is the best method considering these two. Okay, so what is that? Embedded method, decision tree. So basically this method will consider these two method, filter method and wrapper method. Okay, so is there any question till now? Okay, now we will see how to encounter this overfitting. Okay, so PCA, so principal component analysis. So this method can be used to counter this overfitting problem. So, so basically what we do in overfitting, so in place of high dimensionality, make it low dimensional. Okay, so what we will do, we will see this line from another perspective. Okay, so we are seeing from this kind of a front view. Okay, front view. Okay, this graph is kind of front view. Okay, so if we see it from the top view, so what you will see, so you will see that these points are lying on this line. Okay, so if you see from this top view, just imagine, so this point will, you see that it will lies in this line, so you will see like this. Okay, if you see it from the another view, so this is called PC1, principal component 1. Okay, so you can see it from here also. Okay, so what you will see if you see from this angle, you may think that we will see only a point because we are seeing from this angle, but it is not that. So we will just consider an imaginary plane here. Okay, so we'll consider an imaginary plane. So this, all the points will be lying on this line. Okay, this will be like PC2. Okay, so in here only two viewer we are considering. It may be more, say 4, say 5. So what will be the, actually this should be independent of each other. Okay, it will not depend, it will be not independent of each other. PC1 is independent of PC2, PC3 and all this. Okay, so this this view have the orthogonal property. Okay, so orthogonal property means should be independent. Okay, so I will try to show you an example. Okay, through an okay. So I will give you two feature. Okay, the value of this feature. So how to do principal component analysis on these two feature. Okay, so basically there are 10 values. Okay, so in order to calculate this principal component and to do this principal analysis, so we have a concept called covariance matrix. Okay, so how to find out this matrix? Okay, so in order to find out this, so we need to calculate covariance of x comma x, covariance of x comma y, covariance of x y comma x, and covariance of y comma y. So we have to calculate this matrix. Okay, so how to calculate? So we have a formula. Covariance of x comma y is equal to summation of xi minus x bar yi minus y bar and n minus 1. Can anybody tell me what is x bar? So what is x bar and y bar? So basically this is the mean. Okay, so just add all these value and divided it by 10. So I will directly write this value 8.81, 1.91. Just add all this and divide it by number of values in there. So it in here I think 10 values are there. So that's why we will add this and divide it by 10. Okay. So this is the mean. X bar and y bar is the mean. So x bar y bar we got. So what is x I y I? So if it is I value will start from 1. So if it is 1, then x value is 2.5. Then yi value means if it is 1, then 2.4. Okay. So first we will calculate this covariance of x comma x, x comma x. Okay. So what will be this formula? Covariance of x comma x. So the formula will be like this: xi minus x bar, and this will be xi only. Okay, minus x bar. Why? Because the in place of y we are considering x. Okay, so divided by n minus 1. So how to do this? So let's say x. So you have to do it for the all the 10 values. Okay, I will just give you an example for only two values: 2.5, 0.5, Okay, you have to up to do it up to 1.1. Okay, so x minus x bar. So what will be this value? So 2.5 minus x bar, 2.5 minus 1.81. So what will be the value? Value will be 0.69, and have to multiply this also. So this both the value will be the same. So 0.69 into 0.69 will multiply. We'll get some value, and that value is 0.476. Similarly, we have to calculate 0.54, then 0.5 will minus x minus x, so 1.81. Okay, so what will be the value? So value will be minus 1.31. So if we do this, minus minus will be plus. So basically 1.31 into minus 1.31. So the value will be 1.71161. So you have to do it up to this value. Okay. So the sum will be, what will be the sum? So if we add this all after, then you will get a value 5.5490. Okay. Similarly, we have to do it for y. So y, okay. So what is the y value? 2.4 and 0.7. First two value, 2.4 and 0.7. So we will minus, we'll subtract it from the mean. Okay, what is the mean? 1.91. So 1.91. Okay, the answer will be 0.49. Okay, again in folding 0.49 into 0.49, we'll multiply these two, we'll get 0.2401. Okay, similarly for 0.7, we have to gain 0.7 minus oh sorry 1.91. Okay, the value will be minus 1.21. Then again minus 1.21 will multiply in minus 1.21. We'll get the value 1.4641. So we have to do it up to the last value. So what is the last value? 1.1, 0.9. Yeah, so 0.9 will be the last value. Okay, so we have to do up to this. So if we add this all, we'll get a value 6. We have to add all this 10 value. Okay, 0.64641. Okay, similarly, we have to calculate for xy also. So I'll show you x, y, x minus x bar, y minus y bar. So x value is 2.5 and this is 2.4, 0.5 and 0.7 up to last value, up to last we have to do 1.1 and 0.9. 0.9. Okay, so we will subtract it from the mean. Okay, so we'll 2.5 minus 1.81. Okay, so the value will be 0.69. And for y also we'll calculate 0.49. But we have calculated earlier, so you can take this value from there also. Okay, so similarly -1 to 1, and this value is -131. Okay, -1.31. Okay, so you just multiply these two. So multiplication will be different because both are the different values. So 3381, and this will be 1.5851. So you have to do up to the 10th value. Okay, so the sum will be 5.5390. Okay, but in here you just see covariance of xy. How we are calculating? Up to this point we are just calculating in here. Okay, the sum we are calculating, but we have to divide it n minus 1. N minus 1 means 10 minus 1. There are 10 values are there. Okay, 10 values are there. So we have to subtract it from 1. So the value will be 9. So each of this value will be divided by 9. Okay, okay. So I'll I'll continue the next part in the next class. Okay, so it will take some more time. So
Sir,
up to
why is
this
it
point,
divided by 9, sir, not 10?
okay, because n value is number of plus elements. What is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 minus 1, what will be the value? 9.
Oh,
So
okay,
that's why
sir.
it is divided. So that's why it is divided by 9.
Oh, okay, sir.
Okay.
Okay. Okay, sir.
Okay. So up to this point, is there any confusion? So we'll get this C. So after that, we'll get some more complexity. Okay. So I'll just go through this equation. So in the next class, we'll complete this whole principal component analysis sum. Okay. So up to this, you might get confused. So up to this point, I'll stop here. In the next class, I will complete this sum. Okay. Okay. Thank you. And in the next class that I will take, not tomorrow, that I will take 28th Thursday. Okay. And the 29th, I will start your this iris data set that I have shown you earlier class. So I will start do this all this apply this AI algorithm or ML algorithms. Okay. So from Friday I'll start that. Okay. So I will share today link of a Python playlist that I will share it later. Okay. Through that playlist you can learn the basic Python. Okay. Okay. And also Friday, try to be present. I will give an assignment. Okay. Thank you.